Okay, today's lesson is on squares and square roots and the Pythagorean theorem. So first I want to talk about squares and square roots. Squares and square, I'm not going to be able to scroll, I don't think. I guess I'm not. Squares and square roots. A square is the product of a number in itself, is a square. So if you have, for example, if I have 2 squared, look at my calibrated, I'm thinking. If I have 2 and it's squared, it would be 2 to the power of 2. I'm going to try to make this smaller. So if I have 2 to the power of 2, that would be the square of a number. So 2 to the power of 2 is 2 times 2. A perfect square is the product of, or the answer of those whole numbers. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Those answers, 4, 9, 16, 5 times 5 is 25, 25, those are called perfect squares. Those products or those answers are called perfect squares. And then a square root is the factors multiplied to form those perfect squares. Okay? That's called the square root. And we use a radical symbol. That radical symbol is what's used to create or to undo that perfect square. So if I want to take the square root of a perfect, I can't even do this. My board is not calibrated. If I want to take the square root, calibrate this real quick so it works. If I want to take the square root of a number, I'm going to use the radical symbol to do that. And you would use the perfect square to do that. So if I take the square root of, still isn't working, 144, the square root of 144, the perfect square of 144, means that I am going to figure out what the perfect square is, what is the perfect square of 144. And you need to kind of memorize what those perfect squares are. So if I scroll down, and I'm going to have to probably go in my back of my room because I can't scroll. These are the perfect squares from 1 to 15. So the perfect squares are the products or the answers from 1 to 15. So it's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So if I take the radical of 144, your job then would be, okay, the square root of 144 means which one of these perfect squares is 144? Well, the perfect square of 144 is 12 times 12. So we would say that that equals 12. Because that means that I then can take 12 squared. 12 squared is going to give me 144. So the square root of 144 is 12. Because essentially 12 times 12 equals that answer. Okay? So the square root is whatever the square of that number would give you that answer. Okay? And that's the radical symbol. So you're learning today, what you're learning today is really how to undo a square. how to undo a square. So if I have a square of a number, if I have 2 times 2, that gives me 4. And if I have 3 times 3, that gives me 9. So this is 2 squared, and this is 3 squared. 4 squared is 4 times 4, which is 16. And 5 squared is 5 times 5, which is 25. Well, if I want to undo that square, we now have a symbol called the radical symbol. We're going to take that radical symbol, and if I say, okay, what's the square root of 25? That's asking you what answer or what perfect square is that, or what is that problem. So you go to this answer and you say, okay, what number, when multiplied together, is going to give you 25? Or what square is that? What number squared is going to give me 25? Not the square of, but what number is squared to give me 25? The answer is 5. So if I have the square root of 144, what number squared gives me 144? Well, if you look at your list of perfect squares, the square root of 144 is 12, because 12 times 12 is 144. Or if I say, what's the square root of 196? The square root of 196 is 14, because 14 times 14 is 196. Okay? That's what the radical symbol does. The radical symbol allows you to undo a square. Okay? It allows you to undo a square. And that's going to be really important for what we're going to do next. The other thing that I want to talk about with the square roots is it isn't always going to be a perfect square. When you're doing square roots can also be a decimal. And you can use that in your calculator. There is a square root symbol in your calculator. When you have a cheat calculator, you will enter in the number and then hit the square root button. When you have our calculator, you will enter in the square root button and then enter in the number and then hit enter. So each calculator is a little bit different. But you can hit the square root button so you can have the number. Let's say we have the number, I want to know what the square root of 63 is. 63 is not a perfect square, okay? 63 falls between the perfect squares of 49, and it also falls between the perfect square of 64, okay? But it's not a perfect square. So you can estimate it as about, because it's closer to 64, 8. Or in your calculator, you can plunk it in your calculator, and if you plunk that in your calculator, you're going to get an answer, a decimal, and it's going to be 7.937, blah, blah, blah. So you would round to 7, and usually we're going to round to the nearest hundredth, 7.94, okay? So you can round and when you get a decimal, okay? So that will happen, all right? That's all I really have to say about squares and square roots. Okay, if you could turn the page on your notes. Turn the page on your notes to the Pythagorean theorem. The Pythagorean theorem describes the relationship between the length of the hypotenuse and the lengths of the legs of a right triangle. Now, yesterday I talked about, or the day before I talked about what makes up a right triangle. You have the right angle of a right triangle. Ooh, it's still not working on here. I don't want to erase. Well, you have the right. Ay, 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 ay. I can't win here. What did I just do? I don't know. Oh my goodness gracious, I don't know what I'm doing. Something's going weird with my computer. Okay, you have the legs, you have leg A and leg B. The two legs of a right triangle make up your right angle, okay? Opposite the right angle is your hypotenuse. The hypotenuse is the longest side of a right triangle. When we're talking about the Pythagorean theorem is used to determine the lengths of a side, the lengths of the sides of a right triangle. So this is A, this is B, this is A, and this is C, okay? And when we're using the Pythagorean theorem, we're going to use A squared plus B squared equals C squared. Okay, that's our formula. A squared plus B squared equals C squared. It's also written down below. A squared plus B squared equals C squared. That's going to be the formula that we're going to use. So the length, the square of A plus the square of B is going to equal the square of C. The square of A plus the square of B is going to equal the square of C. Okay? And you're going to use the radical symbol when solving this to undo that square of the number. Okay? You're going to use that radical symbol. If you look down below, we have the steps to solve the Pythagorean theorem. The first thing you're going to do is you're going to write down the formula. The formula is A squared plus B squared equals C squared. The next thing you're going to do is plunk in the values that you know. So you're going to look at your diagram and figure out what's A, what's B, and what's C. One of them is going to be missing. Okay? Then you're going to square the numbers that you have. Balance your equation by adding or subtracting to get the variable alone. Take the square root of both sides to undo the square of the variable, and then calculate your answer, rounding if necessary, and then label. Okay? So we have two examples that I have for you. Come on, scroll down here. Oh. Okay. I have two examples that I have for you. The first example has 20x and 25, okay? Now, the legs of a triangle make up that right angle. It doesn't matter, your A and B are interchangeable because A and B are added together. So what is A and what is B really doesn't matter. What really does matter is what is C. And C is always going to be opposite your right angle. Find your right angle, and opposite it is always going to be C. So in this one, you have 20 and x are your A and your B. Opposite your right angle is 25. That's going to be your C. That's really important, okay? I'm going to go to here to do this. So if I draw it, I'm going to sketch that diagram so we have it, just because. So it's 20, that's my right angle, x, and 25, okay? We're going to use the Pythagorean theorem. So step one is to write A squared plus B squared equals C squared. Okay, you should be writing this down as I'm doing it with you, because then you're gonna do the next one by yourself. A squared plus b squared equals c squared. Okay, now the next step is to plunk in the values that you know. We know that this is either A or B, and we know that this has to be C because it's opposite that right angle. So this has to be C, okay? A and B doesn't really matter. So I'm going to say that this is A, 20 squared, plus, I don't know, B squared. And you can say it's X, but I'm just going to leave it B because the variable doesn't make a difference, equals C, which is 25 squared. Okay, so I plunked in the values that I know. The next step then is to square the numbers. Square the numbers that you have. 20 squared means 20 times 20. 20 times 20, you can plunk that in your calculator, that's 400. Plus, I can't square b squared because I don't know what it is, so I just bring down b squared. Equals. 25 squared means 25 times 25. 25 times 25 is 225. Okay? Oh, I did that wrong. I'm sorry. 625. 625. I don't know what I was thinking. 625. Okay, now, the next step is to get your variable alone. You have a 400 plus a b squared equals 625. I got to get this number over here so I can leave that variable by itself. So I'm going to, just like before, just like we did the other day, you're going to subtract 400 from both sides. Over here, you're left with b squared equals 625 minus 400 is 225. That's where my 225 went. I'm going to bring that up a little bit so you can see. Now I have b squared equals 225. Now this is where that radical symbol is going to come in. Okay? B squared equals 225. The only way to undo this square is to take the square root. So you're going to take the radical symbol, and I'm going to do a different color. So I think what I'm going to do is I'm going to rewrite it. B squared equals 225, and you're going to take the square root of both sides. And you have to do it to both sides, because whatever you do to one side, you got to do to the other side. So the square root of b squared is b. Equals, because the square root of b squared is b, because b squared is b times b, which is b then. The square root of 225, well, if you look at our perfect squares sheet, the square root of 225 is 15. And our label would be units. Okay? Now, if you don't want to look at your sheet, you could use your calculator and plunk in 225 and figure the square root, or use your square root button, and you would still get 15. And because we don't know it, if it doesn't have a label, you always use the label units. There is no square units, it's just units because it's length, it's not area. Okay? Okay, now what I want you to do is I want you to do, I want you to do this example. Pause your computer and I want you to do this example and then come back. Okay, the next example has a right triangle. It has A, 12, and 9. Okay, so our first step is to write down the formula. A squared plus B squared equals C squared. You always start by writing down the formula. Then you have to plunk in the values that you know. Okay, so we have what did I do? There we go. Now I gotta find where I am. Oops. What do I keep doing? There we go. Okay. Now we gotta plunk in the values that we know. So I have A, we don't know, so leave A squared, plus B is 9, 9 squared, equals C is 12 squared. Okay? So the next step then is to square the numbers. a squared plus 81, 9 squared is 81, equals 12 squared is 144. Okay? So now, just like before, we're going to subtract both sides from 81. You end up with a squared equals 144 minus 81 is 63. Okay? So now we have to take the square root of both sides to get 60, or to get a by itself instead of having a square with it. So it's a equals, the square root of 63 is that decimal that we just talked about before. So it's 7.937 whatever, so you're going to round to the nearest hundredth, 7.94. 7.94, my label, because there isn't one, would be units. Okay? If you did that right, wonderful, then you are done. If you didn't, then I want you to rewatch the video, because tomorrow when you come back, we're going to go over a couple of these problems in class, and then you're going to get an assignment on the Pythagorean theorem.